what safety procedures should be followed? Yeah, you know, there's going to be warnings on all the battery packs that we assemble and send out to the world. In general, are anything that's going to create a lot of heat, uh, short circuits, or the potential for recharging these primaries. These primary or lithium metal cells are definitely one use. They're not designed to take a charge, unlike, say, something like lithium-ion, where that reaction is reversible. In our case here, we have to take every precaution to ensure that we can't dump current back into these things, as pressure can generated that could potentially create leaks or even explosions. Common sense, which isn't so common anymore, I suppose, but we just need to handle these things with some respect. The SDS will have a lot of the information, and if you do require the SDS, always make sure you ping us. We can send that out to you so that you have that available. It should also be on just about every shipment of these things. And our battery, our website has a safety course available to this course, so you can always go through that as well. Yes, so when we're handling these things, the key places we really want to be thinking about are the big concerns are going to be leaks and explosions, right? Explosion is a pretty exciting word, but it can happen. So we'll go through what will create that kind of scenario, and you can make sure that you're doing everything in your power to ensure that these kind of scenarios can't happen. The warning labels on cells and battery packs are most definitely going to say, don't recharge, don't disassemble, don't overheat, incinerate, or expose contents to water. So just generally good things to keep in mind. I will just quickly talk about exposing contents to water. If your battery fell in the water, it would likely not be the end of the world, right? We're talking about the insides of the cells. The battery pack itself is hermetically sealed. Very little should actually happen if it goes into the water. You want to segregate that and go from there, but we'll talk about that a little later on. Yes, you have an incident when. So the baseline of something might be happening is that a pack is warmer than ambient for an unknown reason. You can generally just, if you pick a battery up, your hand is a very great sensor of temperature. If you feel something that feels warm and you don't know why, this needs to be treated like a potential incident is going on. I've had it where I've been holding on to a battery, and then I give it to somebody, or I put it on the table and somebody picks it up, and just the warmth of my hand was enough to tell somebody that feels warmer than ambient. Why is that? And of course, silly enough, I had just been holding the battery, and so it's now up to my body temperature rather than just sitting at room temperature. But that was great that the person happened to notice even that small difference in heat was something that they could sense. If there's been something going on, you just pulled it out of a hole and it's warm because the hole is a bit warmer. Well, that all makes sense, right? So it's really, if you don't know why it's warm, we should be treating that like something could be going wrong. Pack is giving off a pungent odor. So Bob will talk about this in the upcoming slides, but there's definitely some sulfur dioxide in there that's going to have that rotten egg smell. It's not very nice. A cloud of smoke is coming from the pack. So I think that's a pretty evident issue that something is happening. Pack is on fire, pack is exploding. These last three are, I think, things that you're definitely going to put in the common sense column that needs to be said.
Thanks, Craig. I think it's my turn.
There you go.
I just want to remind everybody, we do have a question and answer thing at the end. So if you see a question and answer link on your screen, go ahead and ask questions if you would like, and we'll try to answer them towards the end. So what happens when the temperature rating is exceeded? There's basically two things. One, above the temperature, you may have leakage. The electrolyte might leak out of the cell through various reasons that Craig already explained. Above the melting temperature of the anode, an explosion may occur. And this chart shows melting temperature of the lithium anode. So the most common cells used downhole are 150C and 165C. The anode melting temperature is around 180C. So if you exceed that temperature, you're very likely to have an explosion. Next slide, please. So what is a battery leak? It's any sort of failure of the glass or metal seal, rim metal, or other breach of the casing, which allows thionyl chloride electrolyte to leak. When that happens, the primary hazards are the corrosive atmosphere as well as an inhalation hazard. And yeah, corrosion, but it can be very, very damaging to anything around it. It could be just as damaging as an explosion to whatever equipment is around it. Thionyl chloride will corrode anything in its path that's metallic. So thionyl chloride, what happens when it gets exposed to moisture in the air? Well, basically it forms HCl, hydrochloric acid, and SO2, sulfur dioxide. The hydrogen chloride will appear as a chalky white cloud when it makes contact with the air, but the sulfur dioxide is colorless, but it has a very, very pungent, irritating odor. It's very similar. I think the best description of it is like smelling salts. If you smell it, you just want to get away from it. It's unavoidable what it smells like. Sometimes it's very hard to describe what it is, but you do want to get away from it. Exposure limit for both HCl and SO2, 5 parts per million. As we said before, HCl is very, very corrosive. SO2 can be very irritating to the eyes, respiratory tract, causing coughing, tightness in your chest. And if you breathe enough of it, it could cause pulmonary edema. This is an example of cells that had leaked. And of course, lithium thionyl chloride cells are stainless steel cans. So you could see what thionyl chloride and HCl will do to the stainless steel after exposure to it for a long period of time. So what causes a battery leak, as we mentioned before, is going over the temperature rating of the cell. So 150C cells, if you go over 150C, you could cause a leak. There's no margin of safety with these things. The temperature rating of a cell is the temperature rating of the cell. If you go over the temperature, you may cause a leak. Where does it come from? Well, as Craig mentioned, there could be glass to metal seal issues or the welds. External corrosion from an outside source. So maybe something is corroding the stainless steel outside, nothing to do with the battery, but it corrodes all the way through into the battery, allowing the electrolyte to leak, which could cause more corrosion, more mess on your hand. A cell explosion. Well, it's pretty obvious what an explosion is. It's when everything flies apart. This occurs when the lithium melts for whatever reason. It melts. There's various reasons why it will melt, including going over temperature, but molten lithium will react very violently with the electrolyte, the thionyl chloride, causing a detonation. The amount of energy that's released is so intense that it will break out of the stainless steel casing. And like I said, it'll be very obvious that something exploded. Primary hazards after an explosion are basically the same as a leak because the thionyl chloride is now vaporized in contact with moisture, forming HCl, SO2, but you also have the immediate danger of shrapnel that can cause damage or injury to people. Here's an example of what an exploded cell looks like, and you can see the jagged, sharp pieces of metal that could cause injury as well as damage. Just another picture. An exploded thionyl chloride cell will be causing a big mess like this. So what causes a battery explosion? The temperature rating exceeded. Most specifically, the temperature rating of the lithium anode exceeded. A short circuit, if the cells are not protected by a fuse, the short circuit may cause internal heating to cause that lithium anode temperature to be exceeded. The lithium anode melting temperature to be exceeded. charging current, you should never charge primary cells. That'll also cause internal heating, causing anode meltdown. Over discharge, if you force over discharge cells, you could cause the same thing as a charging current issue. Excessive vibration or shock. This happens somewhat downhole at times when things go very bad with excess vibration or shock, causing internal short circuits to the cell, causing anode lithium meltdown, resulting in an explosion. And crushing. If pressure, drilling fluid, or whatever crushes cells whilst downhole, you could cause internal short circuits, causing that lithium to melt again. And this is a picture, I just wanted to show this. This is a picture of some downhole batteries cells that had been exposed to a breach in the pressure barrel for the battery, where the pressures caused the cell cases to collapse. This actually was a battery that we took apart after the customer thought that there may have been an issue, but it really was not that evident from the external appearance of the battery pack. But we decided to take the battery pack apart, and this is what we found. It was very eye-opening. And the point of all this is, if you think you had some sort of leakage or some sort of pressure event inside your battery barrel, do not use the batteries again. This could result in an explosion. This could get to the point where the internal components are crushed together, causing an internal short circuit. This one did not explode, but it probably was very close. This next picture is another battery that saw pressure in a downhole battery barrel, and you can see the cells are crushed. So you don't want to get further than that, obviously. Okay, so what do we do if this all happens? Well, as we mentioned, most incidents are the result of a leak or an explosion. Hazards after an incident are the corrosive and toxic atmosphere. So we form HCl and SO2. We're repeating ourselves, but this is very important to remember.